Hello, my name is John William Lynch. This is my CSC 480 assignment 4 part 2 KNN recommender Java file. As my code is a bit in depth, I wanted to run through it first. Up here at the start, there's lots of comments, but essentially I make hash maps and array lists to keep the values of everything. If we scroll down a bit, this is my main method that just runs once the play button is clicked. And now this big portion of code here is simply using a CSV file to read in the Excel file. You will need to change the Excel file into a CSV file using the save as function inside of Excel. After we read everything in, I just parse everything out based on the CSV logic that's described up there. And so my data collection is a bit, but then, so this is my part 1 of the item. So if we are given an int k, which is our neighbors, and a new user string, such as the new users provided here inside of this list, we iterate through every possible user, and we compute their average of the current user and the array that they're with, and then we also compute the Pearson value. So to look at the Pearson value code, the Pearson value takes in two users, a new user, NU, and a current user, CU. I edited this so it works with new users coming in and also current users. Essentially what happens is that we compute the current average of all the ratings of the current user that we have and also the new user. And this was found during the data parsing portion. After we do that, we set some regular values to be placeholders. And then we also get the current user ratings for later as well, just for iterative portions. And this is used down here. And now this is just a Java version of the code that's provided inside the assignment file. Essentially though, but this is based off of the movie example. What I do is I iterate through every row in a user's array, in the current user's array. If it's not equal to 0, which means that the user did rate it, and also that the new user did rate it as well, because if one of these, if a user hasn't rated one of the movies, we ignore it. If they both rated it, we increment the numerator by this equation right here. And then also, because the denominator is a bit more complicated, I did this in portions, but it's just all running through the for loop. So this is based off of it, and we simply skip it if this isn't true. After we find the denominator, we take the square root of it, as this is squaring the denominator both times. And then we divide the numerator by the denominator, and we return that value. After we do that, after we compute the Pearson function, we go back up into our for loop here, and then we add the neighbors based off of. So I put every single user and their Pearson values into a list, and I sort that array list, and then I reverse it so it's descending. And then I have this little for loop here that iterates through the k amount of neighbors, and then it just adds the the neighbors into an array list of found neighbors. So if this was k of 13, it would grab the 13 closest neighbors. If it was k of 4, it would just grab 4 and so forth. Then I return that list of found neighbors. After that, I get the predicting ratings here with found neighbors, and then I get the new user. And the logic here is very similar, but essentially I iterate through the required books and the rated books based on if the user has it equal to 0 or not, which is this logic right here. And then after that, I simply do a for loop through each iteration here. And then this is more so just for the user output. So I wanted to show my Pearson function mainly. And so to actually run my code, this is my new user MAA. So I take in the rated books and the predicted values. And then for each book that's been rated by the user, I check the absolute difference between the predicted values that I determined, and I minus it by the actual values. I return that the mean using this equation. And now to actually run my code, the KNN recommender needs to be in the same as the CSV file. So you can simply click play, and part 1 is for the MEA. So you can enter in users NU1 to NU5. So I'm going to use NU3, and I'm going to use 14 neighbors, like so. My output tells me which books the NU user has already rated. It tells me which ones they haven't rated, and then it tells me the closest amount of neighbors. It tells me also the neighbors that are missing a required book that needs to be rated based on the Pearson function. And then also it gives me the predictions for the required books that they haven't rated. And then this is where my MAA function comes into play. I get the predicted rating and then the actual rating as well. Sometimes it's pretty close, and then other times it's pretty far off. And then I get the absolute error right here. At the end of that, if I wanted to do the second part, I type in 2, and then after that I can type in U1 to U15. I'm going to do U14. After I do that, it's very similar to my other function, as my recommendation is almost identical to my new user prediction. But essentially what happens after this is it gives me the books the user hasn't read, their neighbors, and this is only going to be 4 neighbors, as we have k is equal to 4. And then I get the predictions of what they're going to give each book, and then I return those predictions in order. And so if, I believe user 15 has 4 books that they haven't rated. Excuse me. So if I type in 2, U15, it gives me 4 books here, and I only want to return the top tree, so I get Runny Rabbit, as that's 2.5, My Life So Far 2.0, and then True Believer 2.0. And this portion here at the very bottom with my tree hash map again was very complicated, but essentially that's the way I could sort my hash map using a comparator. Thank you very much.